Welcome to In 5 Minutes. We take problem on beam with internal hinge and carrying uniformly varying load UDL and a couple. Our problem statement is two beams AB and BD are joined by a frictionless hinged joint to form a beam ABD as shown in the figure. So this is the figure of the beam. Draw shear force and bending moment diagram. So we have a beam ABCD of which AB is one part and BD is another part, and this AB part and BD part is connected by means of a internal hinge at point B. Here we see how your internal hinge connection looks like. This is a top view of a beam, this is the AB part and this is a BD part, and it has been joined together by means of a pin joint at point B. Also we see here that your AB part is supported at point A by means of a vertical support, so this represents a kind of a roller support, whereas at point D your beam BD is fixed. And we see that in part AB there is a uniformly varying load whose intensity is varying from 7 kN per meter at point A to 0 at point B, and this variation is uniform. Also there is a couple of 20 kN anti-clockwise acting at point C. So let's solve the problem. First let's draw the support reactions. At point A we'll have a vertical support reaction VA, whereas at point D, which is a fixed end, there will be a vertical support reaction VD, and we assume a supporting clockwise moment MD acting at point D. So we start with the solution. We first consider point B where we have internal hinge. Now the construction of the beam AB and BD is such that due to this internal hinge, the beam will bend in this way. So we can see at this point B, since it is a point at which two members of the beam is joined by means of a pin, the resisting moment at point B is 0. So we can say that bending moment at point B is 0. We see that this is a very important result, that bending moment at internal hinge is 0. So we get additional equation to solve the unknowns of the beam. Now since we see that there are three unknowns VA, VD and MD, we require three static equilibrium equation. Now since there is no horizontal forces, so we cannot make use of summation of Fx is equal to 0. So the third equation used to determine the unknown is given as bending moment at the point of internal hinge is equal to 0. Let's make use of this equation to determine the unknowns. Bending moment at point B is equal to 0, and this is the additional equation to determine the support reactions. So now bending moment at point B is 0, so we can consider either the left hand side of section or the right hand side. If we see in the left hand side there is only one unknown VA, so if we use the left hand side of section we would be able to determine the unknown support reaction VA. So considering left hand side of section, we have the first clockwise moment caused due to the vertical support reaction VA acting at a distance of 9 meter. So we have VA into 9. Next we have the anti-clockwise moment caused due to this uniformly varying load acting downwards. Now this uniformly varying load can be considered as a point load whose magnitude is the area of this triangle, which is nothing but half into 7 multiplied by 9, and this is equal to 31.5 kilonewton, and this downward force is acting at a distance of 2/3 of 9 meter from point B and 1/3 of 9 meter from point A. So I can write it as minus 31.5 multiplied by 6 meter. This is the expression for bending moment at point B, and let me equate it with 0. After solving this, we get the value of VA is equal to 21 kilonewton. Since it is positive, it is upward, so our assumed direction of upward support reaction is true. Next we apply two static equilibrium equation to determine the remaining unknowns. The two equations to be used are summation of M about any point is equal to 0, that is summation of all moments about any point is equal to 0, and then summation of all vertical forces Fy is equal to 0. Now let's apply the first static equilibrium equation, and we take the point as point D. Summation of all moments about point D is equal to 0. Now we'll write the expression for all the moments about point D. Our sign convention is all clockwise moment about point D is positive and all anti-clockwise moment about point D is negative. So first moment we have is, we have a clockwise moment caused due to the vertical support reaction VA, which is acting at a distance of 9 plus 5 plus 3 as 17 meters. So we have VA multiplied by 17. Then we have anti-clockwise moment caused due to this uniformly varying load, and this is acting at a distance of 6 plus 5 plus 3, so 14 meters. So we have minus 31.5 into 14. Then we have an anti-clockwise moment of 20 kilonewton meter. So we have minus 20. Then we have a clockwise moment MD, which is a supporting moment at point D, and this is assumed as clockwise, so we write it as plus MD, and this whole is equal to 0. Now upon substituting the value of VA as 21 kilonewton in this equation, we find that there is only one unknown MD. So after solving this, we get the value of MD as 104 kilonewton meter positive. So that means our assumed direction of the supporting moment at point D is true, and it is clockwise.